Hey everybody, I think this is our last screencast for Honors Chem B for the year. And by the end of this presentation, you should be able to write a balanced chemical equation for the reaction between an acid and a base. Basically, it's double replacement, going to get a salt and water. And you should be able to use titration data, molarity and stoichiometry skills to do some calculations and determine the concentration of an unknown solution. So let's get started here. All right, titration is a method that you use where you have a solution of known concentration and you react it with a solution of unknown concentration. We're going to do a titration lab in this class. We are going to, let's see if I can get one that I think will definitely show up here. We're going to put in the flask, okay, an unknown concentration of an acid, and we will know the volume, okay, because we're the ones that are measuring the volume to put it in there. So the volume will be known, but the concentration won't be known, and we will know the identity of our acid. We will have a piece of equipment called a burette that contains volume and it can be measured. We will have a known, okay, molarity of a base, and we will know the volume of that base that is required to completely neutralize the acid. How are we going to know when our acid is neutralized? Well, do you see this little pink color down here? Remember that when you add phenolphthalein to an acid, it's clear, and then it's clear in neutral. But as soon as you have one drop of base that comes out of there and into this solution, and all of the acid has been neutralized, it's going to make the solution turn pink. And at that point, we know, all right, our solution, our acid has been neutralized. We then know how much base it took to neutralize the acid, and we can do some calculations to find the concentration of our acid. And that's what we're going to work on today. The point at which the hydrogen and the hydroxide counterbalance one another or equal one another to neutralize, that's called the equivalence point. And what you do is you pick some sort of indicator that'll change color as close to the equivalence point as you can. And we're using phenolphthalein in our lab. I know that's a tough one to spell and say, but phenolphthalein is clear in the presence of acid. It's clear at a neutral pH, but as soon as you add one drop of base into that solution, that is, one drop of base comes in there that is beyond the equivalence point, it will cause this pink color to appear, and to quit adding base, and then you can read there's some graduation markings on the burette, and I'll be showing you those on the day of the lab, and you can use those to then know how much base you added. And if you know the concentration of the base, you can then perform calculations, like I said, and find the concentration of the acid. Now, you have to have a balanced chemical reaction, or else you cannot do this method called titration. So in this one, our acid is hydrochloric acid. Remember, acids always have H plus 1. Hydrochloric, that means it was Cl minus 1. So that's the formula of the hydrochloric acid. Magnesium hydroxide. Magnesium is plus 2. And hydroxide is minus 1. So we write the formula for that. They react. When an acid and a base react, a double replacement happens. You get a salt and you get water. The salt is made, remember, from the cation of the base and the anion of the acid. So we would get MgCl2 because magnesium is +2 and Cl is -1. And then the H goes with the OH. Start to balance it. The H is going to go with the OH and make H2O. Then you got to balance it, of course, and that's going to be a 2 here and a 2 here. So that is a balanced chemical reaction between that acid and the base. Now, a question for titration and our lab data might look something like this. Like we measure out 2.5 milliliters of the acid. So we measure 2.5 milliliters of this acid and we put it in that flask and we add some phenolphthalein, which is clear because it's an acid. Okay. And we don't know the concentration of our acid. But when we neutralize it with the base, it takes 15.36 milliliters of base, which has a concentration of 0.25 molar, to neutralize our acid. With that information, we can then use this information right here, the molarity and the volume of the base, to calculate the moles of the base. We can then use the mole to mole ratio to calculate the moles of the acid. And once we have the moles of the acid and the volume of the acid, we can calculate the molarity. Whichever one, the acid or the base, is your known, is the one that you start with. Like the one that you know both the volume and the molarity. Because really it could be the other way. We could have, a base in the flask and not know its concentration and use an acid to change the color of an indicator that we, adding the acid to the base. But in this particular reaction, we know the base, and we're going to start with that one. Okay? So first, when we start with the known, our base, we're going to do a molarity problem because it's a solution. We have the molarity, we multiply by the volume. Remember, that equals the moles of base. Okay? So the molarity was, darn it, maybe I should stick with the highlighter, huh? Whoops. Jeez. Okay. Hitting the wrong thing. So the molarity, the volume has to be in liters because molarity is moles per liter and we need the liters to cancel. So 0.01536 liters. And when you multiply those, you get 0.00384 moles. What is that moles of? Well, that was the molarity and the volume of the magnesium hydroxide. So that is moles of the magnesium hydroxide. Then we want to use the mole to mole ratio from the balanced equation. For example, we know that for every 1 mole of magnesium hydroxide, it requires 2 moles of HCl to neutralize it. How do I know that? I know that because I look at the balanced equation and use the coefficients. This then gives us the moles of the acid because the moles of the hydroxide will divide out. Once we know the moles of the acid, we are then back to doing another molarity problem. Molarity is equal to the moles over the liters. So we can then do another molarity problem to find the concentration of the acid. We have calculated how many moles of HCl were in our solution. And we measured at the very beginning 2.5 milliliters, which, oops, do not want to do that. Uh-oh. It is going to close my PowerPoint. because I bumped this. All right, I'm going to let it discard that. It's going to close it. I'm going to have to start it up again. Hold on. Let's page through here. Sorry about that. Last one of these screencasts that I do. It's the first time I accidentally closed it. I'm learning. So we're trying to calculate, give me a second here, I got to get my pen back. We're trying to calculate the molarity of the acid. We know that we have 0.00768 moles of the acid, and we are measured the 0.0025 milliliters, which is this many liters. And when we divide, and I'm going to round it off to 2 sig figs now because the original concentration of the MgOH2 had 2 sig figs, and now we have the molarity of our acid. Boy, when I closed it, I was pretty close to being done. But you're going to get some worksheets to practice writing the balanced chemical reaction between an acid and a base. Remember, you get a salt and you get water. And then you're going to get some information, some data. Use molarity and stoichiometry strategies. Remember up here, I kind of like the highlighter, it was the molarity, oops, wrong color, can't see yellow on there. It was the molarity times the volume giving you the moles of the known, which was the base in our problem. Then you had to use, the balanced equation and the mole ratio to get the moles of acid that had been neutralized. And you put the moles of acid down here and divided by the volume of the acid, and that gives you the molarity. Good luck with the problems sheet. And we will also be applying this and practicing this in the lab.